Hello everyone, myself Professor Amol Mishra, Assistant Professor of Department of Electrical Engineering in SND College of Engineering and Research Center, Yola. Today we are discussing on the topic motor protection. So first, we are seeing the various motor use or various use of motors in industry applications in fans, blowers, pump, compressors, conveyors, mixers, and cranes, and or any other applications use motors are used. First, types of fault in motors. There are two types of faults in motor. First one is external fault and second one is the internal fault. In external fault, the types of faults are as follows. First one is mechanical load. Second one, unbalanced supply voltage. Third one is a single phasing. Fourth one is a phase reversal. And the internal faults are bearing failure, winding failure, phase and earth fault. Then motor protection summary, in which the thermal overload protection, short circuit protection, earth fault protection, unbalanced protection, block rotor or stalling protection. The thermal stress causes motor failure. Most of the motor failure contributors are failed and failed motor components are related to motor overheating. Thermal stress potentially can cause the failure of all the major motor parts, in which there are stator, rotor, bearing, shaft, and frame. In this figure, in this image, we are seeing the various parts of a motor, in which there are stator, rotor, frame of motor, bearings of the motor, and shaft of the motor are seen. Thermal overload. Consider a motor is a homogeneous body, developing heat at constant rate and dissipating heat at constant rate. Heat dissipation is proportional to the temperature rise. Therefore, T is equal to KIR square in bracket 1 minus e raised to minus T upon lambda. And in this image, we are seeing the rotor parts of the motor, in which rotor bars, then after stator and coil windings are shown. The overload protection of thermal model. The main factors and elements comprising the thermal model are overload pickup level, overload curve, cooling time constant, hot and cold stall time ratio. The thermal overload count or setting criteria for thermal element. Hot and cold curves of the relay are to be met with that of the motor. And pickup current is equal to full load current into second city secondary rating upon city primary multiplied by 1.05. The thermal alarm pre-trip value monitors thermal content and gives an alarm when content reaches 75% of hot trip time. LED indication, thermal lockout. Lockout relay pickups when thermal content exceeds the trip level and indicates. Short circuit protection. What is a short circuit? A motor short circuit protection provided to cater for major stator winding faults and terminal flashovers. The settings. Definite time over current relay element set to about 130% of motor starting current and time delay set at 100 ms. The short circuit element setting is equal to 1.3 multiplied by starting current into city secondary rating upon the city primary. Then we are seeing the differential protection. The differential protection. The differential protection may be considered the first line of protection for internal face-to-face or face-to-ground faults. The summation method with 6 cities. If 6 cities are used in a summing configuration during motor starting, the values from the 2 cities on each phase may not be equal as the cities are not perfectly identical and asymmetrical currents may cause the cities on each phase to have different outputs. The running differential delay can then be fine-tuned to an application such that it responds very fast and is sensitive to low differential current levels. And ground fault protection. What is a ground fault protection? A ground fault is a fault that creates a path for current to flow from one of the phases directly to the neutral through the earth by passing the loop. The ground faults in motor occur when its phase conductor's insulation is damaged. For example, due to voltage stress, moisture, or internal fault occurs between the conductor and ground. To limit the ground fault, the level of the ground fault current connect and resistance known as stabilizing resistance. The R step is equal to ISK upon I0 in bracket RCD plus KR1 plus K plus RR. Phase unbalance. What is phase unbalance? In a balanced system, the three line neutral voltages are equal in magnitude and are 120 degrees out of phase with each other. Otherwise, the system is unbalanced. In the main causes of current and unbalance. The main causes of current unbalances are blown fuses, loose connection, stator turn-to-turn faults, system voltage distortion, and unbalance faults. Effects: the motor winding overheating, excessive vibration, cause motor insulation winding and bearing damage due to current unbalance. Then motor protection stalling. What is motor protection? It happens